Hello, welcome back. All right, today we're going to talk about intersection and union. So this still has to do with probability, so let's take a look at a possible situation. So we're going to have two spinners. So we have spinner number 1 and spinner number 2. Say I break this spinner up, and let's say if you land here you get 10 points, and let's say if you land here you get 5 points. We have a second spinner over here. We're going to break it up into 3 equal spot parts. So let's say all of these are congruent to each other. And you get 1 point if you land here, 2 points if you land here, and 3 points if you land here. So we're going to spin this spinner once, we're going to spin this spinner once, and we're going to go ahead and add the points together to see what are all of our possible outcomes. So when I say what are all of your possible outcomes, what I'm asking you to find is the sample space. So what are all the possible outcomes if I asked you to spin this, and then add the two numbers together? Take a second and see if you could write those down. All right, let's see what you got. You might get them in a different order than me, but that's okay. I'm going to start out with this section first. So if I land here, I get a 5, and I get a 1. I add those together. I have a total of 6 points. 5 and a 2, I could get a 7. 5 and a 3 adds to 8. 10 and 1 add to 11. 10 and 2 add to 12. And 10 and 3 add to 13. So those are all the possible points that I could get in this situation. All right, so we can also organize this information in a table. So I'm going to go ahead and build a table as well. And draw this table big enough so that I can add some information inside of it as well. So there's my first spinner. My first spinner, I could get a 10, or I could get a 5. And that's the way we always do tables, right? Think about the first situation and then the second situation. The second situation, I can get a 1, a 2, or a 3. So now I need to find out the probability of getting those. So what is the probability of getting 10 points? Well, if we go back to the previous lesson, we know that we need to find the degrees. I'm going to assume that that's 90 degrees there. So that's going to be 90 out of 360. To get 5 points, it's going to be the rest of it. So 360 minus 90 is going to be 270. So that's going to be 270 out of 360. If I go here, we know the total degrees in a circle is 360 degrees, but I divide it into 3 sections. So 360 divided by 3 is going to be 120. So each of these are going to be 120 out of 360. Now some of you might be thinking, hey, I could reduce it. Absolutely, go ahead and reduce it. It'll make your numbers so much nicer. All right, so for example, this reduces to 1/4. This reduces to 3/4. This is just 1/3, 1/3, and 1/3. Now remember, to get the areas on the inside, all I have to do is multiply them. So to get a total of 11 points, it's going to be 1/4 times 1/3, which is just 1/12. To get a total of 6 points, right, the 5 and the 1, it's going to be 3/4 times 1/3, which reduces down to 1/4. I'm going to put little parentheses around these. You don't need to, but just to keep it separate. 10 plus 2 is 12. The reason why I'm adding it is, remember I said we're going to add the points together, but the probabilities get multiplied. So that's going to be 1/12. If you want to pause the video and fill the rest of the table, that might be good practice for you. You could do so right now. All right, so 7 points. That's going to be 1/4. 13 points. That's going to be 1/12. 8 points. That's going to be 1/4. So again, these numbers are my probabilities, and then the other ones that say points next to it are my points. So now I've been using kind of the notation, but I guess I should formally explain what I'm talking about. If I'm talking about an event, I'm talking about a particular outcome. In other words, the probability of some event is going to equal some fraction or some decimal. That's what I've been asking you, and I've been using this notation. It's as probability of something. So for example, if we go back to our situation with the two spinners, I could say the probability of getting 5 points, or a probability of getting a 5 and a 3. The probability of getting a 5 and a 3, if we go up here, the probability of getting a 5 is, we already looked at that, that's 3/4. And the probability of getting a 3 is just 1/3. I multiply those two together and I get 3/12, which reduces to 1/4. And that's what I got right here, right? A 5 and a 3 comes out to be 1/4. So that's like saying right here, the probability of getting a 5 times the probability of getting a 3, and then I do the math, and that's where I got that. Now, the notation I'm introducing today is intersection union. This is an intersection. We could write it as the probability of 5 and 3. That's going to equal the probability of 5 times the probability of 3. Or I'm going to just use general notation. The probability of A and B, the probability of any two events, the probability of any two events is the probability of A times the probability of B. And we call that an intersection. So now watch this. The way you're going to remember intersection and this symbol, doesn't that look like the letter N? There's a letter N right here for intersection. We could go back up here and just highlight that. That's intersection. So now we have another situation which is called union. We say that's the probability of 5 or 3. The probability of getting a 5 or a 3 is this. I'm going to think about it like this. 5 or a 3, here are all the ways a 5 came up, right? And here are all the ways a 3 came up. I physically took my answers for 3, my answers for 5, but I overlapped it right here, so I just have to subtract that part off. So in other words, I'm taking these probabilities. I'm going to redraw that so you can see it while I write it. So basically what I did was, for the 3s, I had 1/12 and 1/4. Are my probabilities. For my 5s, I had 1/4, 1/4, and then that 1/4 again on the bottom. So it's all of these sitting right here, right? If I take this answer and add it to this answer, I've got to subtract off the one I've counted twice. So in other words, if I take my total going across, we know that that's going to be, or my 5s, That's going to be 3/4. I'm going to add it to the probability of a 3, which is 1/3. But then I counted this one twice in this overlap, so I've just got to minus that off, which is 1/4. So that actually, if I stick that all in my calculator, that comes out to be 5/6. So breaking it down like I did up there, I took the probability of getting a 5 plus the probability of getting a 3 minus the overlapping section, the probability of 5 and a 3, and I get my answer. So the actual way to look at union is this. The formula that you'll see in a textbook, A union B is the probability of A plus the probability of B minus the probability of A and B. This is a huge formula, so you're going to want to have this. All right, and this is union. The letter U, if you notice, there's your U. And if we go back up to the top, we could circle the U up there too. All right. Now, one of the things that I want you to make a strong connection to, and an intersection go together, or and union go together. There is more than one way to find the union. This is the general formula if you want to take the probability of A plus the probability of B minus the overlap. The other way that you could get 5/6 without doing any of the subtraction, just add up all those numbers together. So just take 1/12 plus 1/4 plus 1/4 plus 1/4. If you use the calculator with that, that's going to be 5/6. So there's two ways to think about it. Adding them all up, or giving the probability of a 3, probability of 5, and subtracting off where they overlap. All right? All right, thanks for watching. I'll see you next time.